In this video, we're going to be looking at probability tree diagrams. In this first example, I'm going to be looking at playing a game of badminton. Okay, so when I play my game of badminton, of course I can win or I can lose. So I'm saying the probability of me winning is 0.7. And of course, since probabilities need to add up to 1, the probability of me losing must be 0.3. Now, how do we make this into a tree diagram? So the scenario is that I'm going to play 2 games of badminton. Let's do the first part of the tree diagram to represent my first game. So at the end of the lines, we write the outcome, win or loss. And along the lines, we write the probability. And that's my first game done. So now I need to draw the next part of the tree diagram. In the next game, I can win and lose. And if I lose the first game, the next game I can also win or lose. Okay, so here I'm drawing my second game. So if I win, of course I can win or I can lose. And remember that goes at the end of the lines. And remember we write the probabilities along the lines. Now in my second game, nothing is changing. So the probabilities are the same, 0.7 and 0.3. Now in real life, it might not be the case that it stays exactly the same. But to simplify the scenario, we're going to just keep it the same. So if I win, the probability of me winning again is the same as it was in the first game. And in the exams, when you're filling in your tree diagram, just remember that these numbers always need to add up to 1. And that goes the same for these 2 numbers. Okay, so let's now carry on finishing drawing our tree diagram. So again, if I lost the first game, in my second game I can win and I can also lose. Now I also need to write the probabilities in, and remember they simply just stay the same. So winning is 0.7 and lose will still be 0.3. Later we're going to do examples where it might be different on the second time. What is the probability of me winning both games? So I'll be going along my tree diagram like I've highlighted here. Now, what do we do with those 2 0.7s? Because that's what I went past. I went past 0.7 followed by a 0.7. Whenever we go along our tree diagram like this, we always times the 2 numbers. So the key thing here is when we go along our tree diagram, we multiply. And that gives us 0.49. Now let's look at the probability of winning one game. Now this one is slightly complicated. If I had just said work out the probability of winning followed by loss, there's only one way that can happen. Win followed by loss. So it would be 0.7 times 0.3. However, here I've said win one game. Now there's 2 ways that can happen. It could be a win followed by a loss, or it could be a loss followed by a win. Both of them answer the question. Both of them have one win. Now what do we do in that scenario? What we do is work both of them out. So the first way of getting one win, we're going to do win followed by a loss. That's this highlighted route. And of course, when you're going along the tree diagram like this, as I said before, you multiply. And that gives us 0.21. Next, we'll do loss followed by win, because this also answers the question of having one win. And here you can see it'll be 0.3 followed by 0.7. And again, we multiply when we go along the tree diagram. And that also gives us 0.21. Now, what do we do when we have 2 answers like this? Do we give both of them? No, we simply add the 2 answers. So in a scenario when you've got 2 answers, you simply add them at the end. And there's many ways you can be questioned on this. I'm just going to quickly talk through a couple more before I go into my next example. They might ask you to work out 2 losses. So 2 losses would be this route here. And of course that will simply be 0.3 times 0.3, which is 0.09. Again, they might ask something a little bit more complicated, like having the same result in both games. What's the probability of having the same result in both games? And of course there's 2 ways that can happen. You can have a win followed by a win, or you can have a loss followed by a loss. And just as before, you work them both out and add them up. Okay, so in this next example, it's going to be slightly more complicated because on my second pick, things are going to change. In the first example we did, it did not change. And of course, in the first example, we had 2 spokes coming out. And here we're going to have 3. And don't worry, it doesn't make it more complicated having 3. So let's see how that looks like. So let me tell you about this example. So we've got 5 jam sandwiches, 3 chocolate sandwiches, and 2 peanut butter. So here I've written my 3 choices at the end of the spokes: jam, chocolate, and peanut butter. Now I need to write probabilities along the lines. So what is the probability of having jam? Of course, there's 5 jam sandwiches, but how many total is there? And if you add them up, you see there's 10. So it'll be 5 out of 10. Okay, so how many chocolate sandwiches have we got? We've got 3. So it's going to be 3 out of the total, which is 10 again. And lastly, how many peanut butter sandwiches have we got? We've got 2. So it's going to be 2 out of 10. Also, you know these 3 numbers have to add up to 1. So that's another way of knowing that it's going to be 2 out of 10. Okay, so let's go ahead and draw the spokes for the second pick. Now comes the tricky bit. The probabilities are not the same when I'm picking my second sandwich, because in this example, I'm not replacing it. If I had replaced the sandwich when I'm picking the second time, yes, they would have stayed the same. But I'm not replacing it, and that's the key word you're looking for. Is it being replaced or is it not being replaced? So in this example, we're not going to replace. Now the fact that we're not replacing it changes all the probabilities on the second pick. Okay, so I've picked a jam. What's the probability of me picking another jam sandwich? Now remember, there's not 5 left now. Since I've taken one, there's 1 less. So if there's 1 less, there must be 4. Now it's not going to be 4 out of 10, because if there's 1 less, the total is also less. So it's going to be 4 out of 9. And chocolate, there's still 3, because remember I've gone this way. So if I've gone this way, I've taken only a jam. So the chocolates are still all remaining. So there's still 3 chocolates. However, it is out of 9 because there's 1 less jam. And peanut butter, well, all the peanut butter is still left. So there's 2. And again, it's out of 9 because of that missing jam. Now, if I've picked the chocolate, of course, all the jams are still there. So there's still 5 jams. And again, it's out of 9 because there's that chocolate missing. Now, chocolate this time is not going to be 3 because I've taken a chocolate. So it's 1 less chocolate. So it's going to be 2. Out of the total is still 9. Now, if I've taken the chocolate, of course, peanut butter all still there. So it's 2 out of the total, which is 9. And lastly, if you're taking a peanut butter first, let's work out the probabilities of the second pick. Okay, so jam, remember, if we're taking a peanut butter, all the jam are still there. So it's going to be 5 out of the total. Now, what is the total? Of course, it's 9 because there's 1 less missing, which is that peanut butter. Now, the chocolate, they're all still there as well because I've only taken the peanut butter. So that's 3 out of 9. However, the peanut butter will be a little bit different because we've taken a peanut butter. So there's 1 less peanut butter. And here we've filled up a whole tree diagram. Now, once you've done a couple of these, you'll get the hang of it. It's not that difficult. Okay, so let's work out some probabilities using our tree diagram. Let's start with the easy one. What's the probability of having 2 chocolates? Now, going along our tree diagram, we've got 3 out of 10 followed by 2 out of 9. And what do we do when we go along a tree diagram? We multiply. And you get 6 out of 90. And of course, if this is your final answer, you can cancel it down as well. Now, let's think of a slightly more trickier question. What if it said, what's the probability of us picking 2 the same sandwiches? Now, the reason why that's tricky is there's 3 ways that can happen. It could be a chocolate followed by chocolate. It could be a jam followed by a jam. And it could also be a peanut butter followed by a peanut butter. So what would we do? We'd work all 3 ways out. Okay, so we've already worked out chocolate followed by chocolate. So we can use that answer. So we need to do jam followed by jam, and we need to do a peanut bar followed by peanut butter. Now, if you remember from before, if we've got multiple answers, what do we do with them? We add them up. And that will be your answer. Of course, you can cancel your answer down as well. Now, just a tip. The other answers you worked out, it's a good idea not to cancel them down, because as you noticed, it made it easier for me to add them up. So only cancel down if it is your final answer. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.